Hello class. In this video, I'm going to introduce you to mathematical modeling. In a typical mathematical models, for example, we might have a profit equal to revenue minus expenses. And in the mathematical modeling, we want to specify that in a mathematical term. So for the profit equal to revenue minus expenses, we can also write it as profit equal to a function f of revenue and expenses. And in a more specific way, we can even simplify it to y equal f parentheses x1 and x2. So this equation becomes very abstract because we try to use mathematical notation to express the meaning of profit equal to revenue minus expenses into y equal to f in terms of x1 and x2. And in this case, x1 stands for revenue, x2 stands for expenses, and the y denotes the profit. The f actually is the function we use to connect the profit and the revenue and expenses. Of course, that's still a very simple model. If we go to a more generic mathematical model, we can have y equal to f parentheses x1, x2, x3, x4, keep going until we hit xn and parentheses. So in this very generic function, the y is the dependent variables. Sometimes we also call it the bottom line performance measure. The x1, x2, sometimes we generalize as xi, and in this case, xi is the independent variable. And of course, those independent variables typically have an impact on y. In other words, those independent variables are going to be changed by themselves independently, but eventually they are going to have an impact on the dependent variable. And that's another reason we call it y depend on those independent variables. And the f actually is the function defining the relationship between the independent variables and dependent variables. In all kinds of mathematical modelings, we can separate them into three major categories. The first category we call prescriptive analytics. In prescriptive analytics, actually we know the form of the function, but we do not know those independent variables. For example, if you go to see a doctor, the doctor might not know all your problems, but they do have the formulate over there. They know if you have these symptoms, then to give you a certain type of the prescription and then solve your problem. But before you see the doctor have no idea about your symptoms, so they have to wait until they see you, identify those symptoms, the so-called independent variables, and then use the function in their mind, the typical medical procedure, and then give you the prescription. So that's another reason we call it prescriptive analytics. In prescriptive analytics, actually we have many different types of tools. For example, we have linear programming, we have networking, we have integer programming, we have critical path methods, we have EOQ, we have nonlinear programming, we have Go programming, we even have multi-objective linear programming. The second major category is called predictive analytics. In predictive analytics, actually you don't know the function of the f, but you do know those data, those independent variables. You can think about this. You are in a marketing department, you have all kinds of sales data, and you know all your customers. But you don't have the best function to figure out what is the best solution to sell those cars to your customers. So you try to figure out what is the function over there so that you can better predict your customers, so that you can sell to your customers in a better way. So the function, try to figure out the function f, become the key task of predictive analytics. In predictive analytics, you have different types of tools like regression, time series analysis, descriptive analytics. The third major category is called descriptive analytics. In descriptive analytics, you do have the data, but you don't know those independent variables. So you try to describe what are those independent variables using the function in your mind. And you try to describe all the data you have. In typical descriptive analysis approaches, you do have simulation, queuing, inventory models like that. And in the mathematical modeling, you do need all these three different types of analysis tools to do a perfect analysis of your business problems. The reason for us to apply different types of mathematical modeling is because we do have different types of advantages over here. The first advantage is economics. It means we can save money for using those mathematical models. Let's try to consider a case. In Amazon optimal pricing, we know that right now Amazon has millions of items on Amazon.com. And there's one key task for Amazon is try to figure out what is the optimal prices for those different types of items. Quickly, just probably in several minutes. We know that, I don't know whether you have that experience that when you are checking on Amazon and sometimes when you check out, the price change. And that's because Amazon is using optimal pricing over there. You cannot imagine that you can ask a human being to do the optimal pricing for all those millions of items on Amazon.com right now. So we have to apply mathematical modeling techniques, typically a software sitting in a supercomputer to solve the optimal prices for all those different types of items over there for you. And the software can solve the optimal pricing just in several minutes. And right now, even you have 1 million human beings over there, they might not be able to figure out the optimal prices for you in several minutes. So that's the reason we need to rely on mathematical modeling right now. And it can help us solve the problem multiple times in 1 day and every day in whole years. And that can save us a lot of money. And of course, because we can run the model quickly, so we can also get the optimal solution much quicker than we ask the human being to solve the problem for us by hand. And of course, for whatever models we are talking about, we need to make sure it's feasible for us. It means the optimal prices we apply in Amazon right now definitely is feasible for Amazon. It's helping them making money for the company and for, of course, from the customers we are right now. And of course, mathematical modeling can give us all kinds of managerial insights sometimes. You think about that. Mathematical modeling right now can deal with a very abstract independent variables and dependent variables. And as a human being, we never think of that before in a very concrete examples. So in mathematical modeling, we can get some very surprising insight we never think of in the past. And those surprising insights can help us figure out what is the better and optimal decisions for the company.